Hello class, this is Mr. Coy. So we're doing a second velocities graph because we are not done with this topic. So what you should know is how to interpret a velocity graph, how to solve for acceleration, and how to solve for displacement, which we know as is change in x, also known as change in position. So in your large packet, turn to page 9, the one that says the rocket up at the top. So we're going to be doing this together, so please pause the video, attempt to do it. I will go through it 1 through 12 in order, so if you keep going, if you get stuck on one, come back to the video. But try it first. Alright, so now that you've tried it, before I get into solving each one, let's just talk about what's happening here so you understand it. So we can see this first area. So it's a rocket, right? It starts here on the ground at 0 velocity. Or actually not on the ground, looking at it. Or no, maybe, yeah. So it starts here, alright. Rockets have 2 burners, which you'll notice it mentions in 6, where it talks about where's the first stage burnout. That's when the first set that powers the rocket burns out and it goes to the second one. So this first set here, right, we have a really high acceleration. Alright, then after that, we have a different acceleration. Then finally, we have all a negative acceleration here. So we still have a positive velocity here and a negative velocity over here. But then remember, the slope of each of these is the acceleration. So in the beginning, we do have a positive acceleration. And then once we hit this line here, we now have a negative acceleration from here onwards. So let's think. So we have a rocket, we shoot it off. It starts off right here going really fast in the beginning. Alright, we burn out our first rocket fuel, then we go to this next set. So something big is happening right here. It changes. Alright, so think about it. So it stopped positively accelerating. So it ran essentially out of fuel at this point. It burned all of its engines out. So now from here, it's still going up, but it stopped accelerating, right? Now gravity is starting to pull it down. So this negative acceleration, this huge green line, is all from gravity pulling it down. So think of it as actually in position. What's happening? We have our rocket. It's going up, and then oh crap, it started slowing down, and now it's crashing back to Earth, or except it explodes first. So here, at this point, is where we finally have a 0 and a negative velocity. Think of at the top here, our slope is 0. We got a 0 velocity here. That's this point where it now suddenly starts plummeting to Earth. So now we kind of have a better idea of what's actually happening to this rocket. And now we will go and solve the questions. So on to the questions. What is the rocket's velocity after 6 seconds? So since this is a velocity graph, we can just look at the point at 6 seconds and go up to where the velocity is. So you can see that it's up at 160 meters per second. Make sure you include your units. Alright, during which interval is the acceleration the greatest? So remember, acceleration is equal to delta V over t. So the change in velocity over time, which is essentially, remember, going to equal our slope. So go ahead, you can either figure out the slopes, or you can actually just look at it and see which one of these slopes is the steepest. Hopefully you can look at it and see it's the first slope. So you can either label some points in here. Each point would be A, B, C, and so forth. Or you can just say from time equals 0 seconds to time equals 2 seconds. That's our interval, right? Because we went from 0 to 2, and that's where acceleration was the greatest. Alright, this is another one where you can just look at the graph because it's asking at what points is the velocity equals 0. So we just have to figure out where does it touch the 0 line of the origin for velocity. So right at the start, its velocity is 0, right? Because it's just starting out, it hasn't gone yet. And here. So remember, this point is the point in midair where it starts to turn around. And right at the top, you know, if you throw a ball up right at that top point, it stops and has to turn back around. So that would be at t equals 0 seconds and t equals 22 seconds. Alright, number 4, what is the rocket's velocity when it explodes? Again, this is a velocity graph, right? We just have to figure out, we can read the problem, it explodes at 32 seconds, so then determine what that velocity is. So go and look on your graph. So that'd be a negative 100, make sure you include the negative, and always include your units, a negative 100 meters per second. So it's falling pretty fast. Alright, so looking at this question, you may wonder, what is interval BC? Excellent question, because that was something I should have written down for you guys. It's A, it's B, C, D, E, and F. So what they mean, interval B, C, they mean the line between B and C. So what is the acceleration at this point? So if you didn't solve it because you weren't sure where BC was, go ahead, pause, solve it now. Alright, so remember, acceleration is our change in velocity over time, aka our slope. So we need to find the slope of that line. Remember, you can pick any 2 points. I'm just going to pick the endpoints for simplicity. So our first point is, let's do our final point first. So we go from 80 to 160. So if you take off the zeros, that's 16 minus 8. So our velocity change is 80 meters per second over our change in time. We started at 2. We go over to 6. So that's 6 minus 2. That gives us 4 seconds. Remember, include your units because now we have 2 seconds on the bottom. So our units are going to be meters over seconds squared. Then you do 80 divided by 40. It would give you 20 meters per second. Alright, question 6. At which point did the first stage burn out? So that means at which point did the first engine burn out? Because rockets have 2. If you've ever watched a launch, you'll see it starts with 1. You know, something breaks off, that fuel's gone, and it starts off another engine on a different set of fuel. So at which point did the first stage burn out? Let's think about this. What do you think will happen at a burnout? If we're switching engines, what's going to happen to our acceleration, right? No 2 engines are going to have the exact same acceleration. So we can see it's still going to accelerate upwards or have a positive slope because it's still going up. So we can see that right here, it's changed acceleration. We don't necessarily know for sure, but we can assume that at t equals 2, our first engine burned out and our second one started. So that would be at t equals 2 seconds. Alright, so 7. How long does it take to reach its maximum height? This is a little tricky because if you look at your graph, it's easy to say, oh, right here, there's a maximum. However, remember, that's the maximum velocity it's going. But this whole time is still a positive velocity, so it's still going up. So if you think of this, I'll have to draw this graph kind of short. If you think of this as what's actually happening in real life, right? It's increasing. And then at some point, oh no, the velocity is now negative. So it's not the best curve to draw, but you can see right at this point, it was increasing up until this point. Not very fast, right? But it was increasing up until the point where it started falling down again. So, right, 0 velocity is right before it starts to fall down, and this is where it's falling down. So your maximum height would be all the way up until it starts going down, which would take us to t equals 22 seconds would be its absolute height. So when you're looking for maximum height, it always wants to be where velocity equals 0, because that means it's about to start falling again. It's already gone up as much as it can, and now it's going to start to fall. So that is where its maximum height is. Again, if this confuses you, think about a ball. When you throw it up, once it leaves your hand, it's going its fastest, and as it reaches the top, it slows down, hits 0, and starts going back down again. So this is how far does the rocket travel in the first 2 seconds. So remember, we can figure out how far does the rocket travel. Remember, how far something goes or how far its change in position is the same thing as displacement. So don't be confused by the wording. It's just asking, its displacement, its change in position, how far does it go? So we know how to solve that. That is finding the area under this curve. So remember, area of a triangle is half base times height. So we get our base is 2 seconds, include your units. Its height is 80 meters per second, and it's 1/2. So remember, cross things out before you solve it and make it easier for you. Oh look, we got a seconds, cross them out. We have a 2 on the top, a 2 on the bottom, cross it out. Now we just end with 80 meters times 1. Hopefully you can solve that. That is 80 meters is our displacement, or how far does it travel in the first 2 seconds. Alright, again, it's asking for maximum height. Remember, we started on the ground, we're shooting a rocket up. So maximum height is going to be, again, the same as the displacement or the change in position. So we're going to need to find it the same way. You do have to know, where did its height stop increasing? But hopefully you remember from question 7 how long it takes to reach maximum height. That gives us to the 22-second mark. So we have a huge figure because we got to figure out the space in all of this. So you might be tempted to make it one huge triangle, but remember, this is not the same slope, right? There's a little bit of extra space in there, so you will have to break it up into multiple objects. How you break it up is up to you. I would break it up here. Plus, we already know what that space is because we just figured it out last problem. Right in this area, it is 80 meters. Then I would break it up into square here, or this rectangle, and this triangle, and then this is our huge triangle over here. So that's going to be a lot in that one space, I think you can tell. So let's first do this section. I'm just going to name it B. It's a triangle, so it is going to be half base times height. So half, and then our base from here, 2 to 6, our base is 4 seconds. Then our height is from 80 to 160, so that will give us 80 meters per second. We can cross out your seconds. Oops, and I wrote 8, not 80. 80 meters. Then I like to do some simplifying first. It makes my life easier. 4 is the same thing as 2 times 2. So I can cross out that 2 and that 2. I'm left with 2 times 80. That'll give us 160 meters. Let's move on to our next shape. Let's do this one. Remember, that's just base times height. No 1/2 in there. So that's going to be the same base of 4 seconds times a height of 80 meters per second. Cross out your seconds. And you can either plug this in your calculator. Remember, 8 times 4 is 32. And then you're going to have to add your 0 back on for that. So 320. It's 320 meters. Then our last huge shape, we're going to get a really large number here. Let's just call this area D to make it easier. So that is a half. It's still a triangle. Your base is from 6 to 22. So subtract them. It would give you 16 seconds. And then you need the height, which is the full 160 meters per second. Again, I would probably type this in your calculator. Remember, cross out your seconds. So that's 16 times 160 divided by 2 would give you 1,000. Remember, this rocket has gone really high, 1,280 meters. Now remember, you got to add all these up. Don't forget that original 80 meters we had from the last problem. And add all of those up. So we add all those up. That's 160 meters plus 320 meters plus 1,280 meters plus 80 meters gives us 1,840 meters. Alright, so this is another displacement problem because we're talking about height. However, we want to figure out where it exploded. So remember, it started decreasing in height during this time. So here's what you have to do. Any area above the curve is positive. Any area under the curve is negative. So you'll want to use the area you found last time in problem 9. And that was, or at least, the height obtained. It's 1,840 meters. So that's all the positive area. And you need to subtract out whatever area we find for this triangle here, because, right, it started decreasing in height. So let's find the height of this triangle. So remember, it's 1/2 base times height. Its base is from 22 to 32. Subtract those. You get a base of 10 seconds. Then from here you find the height. So it goes from 0 to a negative 100. Negative 100 meters per second. Then we can figure out, multiply that together, divide it by 2. Cross out your units. That'll give you 1,000 if you multiply those together. Divided by 2, half of 1,000 is 500 meters. It's negative. So just make sure that you do subtract it. You can either add them together and make this negative, or just keep this positive and subtract them. Either way, make sure that your number is smaller at the end, because it is, remember, falling. So 1,840 meters, subtract 500 meters, that'll give you 1,340 meters is its height when it exploded. Alright, so this is what happened at point C. If you remember from early problem, that first part is B, this is A, B, C, D, E, F. So what happened at point C? So this is not, I don't need a number out of this, I just need what happened. So remember this, we decided this was where our first engine burned out and then our second engine took over. We only have 2 engines though. So what happened at point C? It's not falling yet at point C, but it stopped going up. It stopped increasing acceleration, right? It stopped accelerating. It's now decreasing velocity, but still going up. So this is the point where it still has positive velocity, but now gravity is starting to pull it down. So gravity is slowing it down. That is what's happening at point C, where now all engines have burned out. Alright, so last question. What happened during interval EF? This is E, this is F. So what happened during that time? Alright, this is where velocity equals 0, so it's the top of our curve of when we threw something up is now started to fall. It now has a negative velocity. That means it is, plummeting back to Earth. That is what's happening right here. It's a negative velocity. It is now falling due to gravity, if you want to be really specific, right? This is gravity that's making it fall back to Earth. And you are now done. Hopefully this helped you understand more about velocity and time graphs and how to do problems based on them.